Okay, welcome back to our class for midterm week module number 3. So our topic is about number of brushes. So we have here for lap winding, the number of brushes is equal to the number of poles. So take note, sa number of brushes, sa lap winding, ang atoang number of brushes is equal sa atoang number of poles. And for our wave winding, the number of brushes is equal to 2. So in generated EMF in the armature, we have here our formula. So E is equal to P, where P is our number of poles. N is our speed armature rotation in revolution per minute or RPM. And Z is the total number of conductors in the armature. And our angle phi is our flux per pole divided by 60 multiplies ato ang A or number of armature current paths. So in Webers, so we have here given, while sa Maxwell, so we need to multiply times 10 raised to negative 8. So where E is our generated voltage in volt ang atoang unit. So take note for our formula for generated EMF. So let's have an example for this. A 4-pole DC armature has 124 simplex lap coils, each having 2 turns. The flux per pole is 0.015 Weber. Calculate the voltage appearing across the brushes when running at 150 RPM. So take note, giingon sa problem, 2 turns per coil means 4 conductors per coil. So take note to, no? So first we need to write our given from our problem para mas madali ra ma-analyze. So na siya given nga P, which is 4. And naa siya N nato, which is 1500 rather RPM. And we have also our A, our Weber. Flux per pole nato. So naghatag siya og 0.015. And our Z, so naghatag siya 124. But giingon nga 2 turns per coil. So we need to multiply times 4 conductors per coil. So nasulat na nato. So our A will be, so giingon sa problem, simplex. That's why we have sa lap winding, we have 1 times 4. So substitute sa ato ang formula. So our formula is E is equal to Pn multiplied our Z angle or flux per pole divided by 60 A. Ano tayo given? Substitute our data. 1,5. 124 times 4. So, irog na to. Our flux per pole is 0.015 divided by 60. 1 times 4. So, our voltage appearing across the brushes is 186 volts. So, therefore, this is our final answer for our problem number 1. So, let's proceed. So, after assembly on the generator, the number of poles or P, number of armature windings Z, and the number of parallel paths A will become constant. So, giingon, if after daw ma-assembly sa generator, so kaning tolo, kaning P, Z, and A will be constant. So, we have here, if constant, kaning K. So, we have here our formula if become constant. So, we have E2 divided by E1. So, N2 over N1 multiplies ato ang flux per pole 2 divided by flux per pole 1. So, magamit na to ng formula if ang ato ang number of poles, our number of parallel paths will constant. So, we have here K is our proportionality constant. So, let's have an example for this formula. So, a DC generator is run at 800 RPM, is at and generates a voltage of 110 volts. What will be the new generated EMF if the flux is decreased by 20% with the speed increased to 1,200 RPM? So, sa problem, we need to write first our given. So, naghatag siya, no? So, 800 RPM. So, we have our N1. And our E1 is 110 volts. And we have our N2, which is the 1,200 RPM. And our so giingon ang flux daw nato is decreased by 20%. So therefore our flux per pole sa number 2 will be so decrease by 20%. So therefore we have 0.8 sa tuang flux sa 800 o 110. So, ang unknown na to sa itong problem, so, ang gipangita, what will be the new generated EMF? So, therefore, our unknown will be the E2. So, to solve for that, we need to use this formula above E2 divided by, so we have here E1 is equal to N2 divided by N1 multiply sa tuwang flux per pole 2 divided by flux per pole 1. So given natay data nga given sa ato ang E1, we have here 110. Our N2 is 1,200 and our N1 is 800. So our Q2 will be decreased by 20%, so we have 80%. That's why we have 0.8 flux per pole of 1 by flux per pole. So cancel. So to solve for E2, so we have our answer. Answer will be 132 volts. So this is our final answer for problem number 2. So let's proceed for another topic. We have here power losses in DC generators. So naabot tayo losses sa tuang DC generators. We have here copper or electrical loss. So when an electric current of I ampere flows in a resistance of R or ohms, heat energy is lost at the rate of I squared watts. So formula for copper loss sa DC generator, we have I squared multiply sa tuang R, our resistance. Second, we have mechanical or friction loss. When machine is running, there are various frictional forces to be overcome, which requires a continuous expenditure of energy and results in heating the rub parts. And number 3, we have magnetic loss or core loss or iron loss. These are heat losses in the iron of the armature. Armature core produced by changes in the direction and the magnitude of the flux. So kaning core loss mostly makita nato ni siya sa armature core nato. Next, we have stray load losses. These are load losses not covered by the above losses as outlined. The stray load losses shall be taken as 1% of the output. So take note that include these losses only when it is given or when the answer in computing efficiency is not available from the choices. So mostly kaning mga losses na to, magamit siya sa efficiency if we need to answer. So let's have here our formula. So PED. So kaning ED is eddy current loss. So we have K. So atong K, remember proportionality constant of T squared, which is atong T is the thickness of the laminations of the core, and B, the flux density squared, and F, frequency in hertz squared multiplies atong V, which is the volume of core. So mo niya to ang formula if ED losses. If hysteresis, so we have here K constant multiplies atong flux density raised to 1.6 multiplies atong frequency and the volume. So take note, assuming T and V constant, frequency F is directly proportional to speed N, and flux density B is proportional to flux. So giingon, if constant ang ato ang thickness and the volume of core, so ang ato ang frequency is directly proportional sa ato ang speed. And our flux density is proportional po sa ato ang flux. So we have here, if given ang ato ang flux and our speed, for ED current. So K constant, N squared, flux squared. And for hysteresis, we have constant multiply sa tong speed and our flux raised to 1.6. The exponent of 1.6 of B in the formula is called Steinmetz exponent. So mapansin na to no, natay anong na may 1.6 diha ma'am sa tong hysteresis. So ang ginatawag di ana is Steinmetz exponent. So constant na siya. In modern machines rather, the value of the exponent is closer to 2. If it not specified, just try using 1.6 or 2. So if wala gi-classify, pwede ta mo gamit 1.6 or 2. But mostly ang ginagamit nato sa tong formula is 1.6. So let's have an example for this problem. So a DC machine is run at 500 RPM. The ED current losses and hysteresis losses are found to be 100 and 200 watts respectively. At what speed will it be run to reduce the core losses by 20%? So take note, giingon sa problem nga, since there is no given data sa ato ang flux, then i-assume nato the flux is constant. So wala may given. So therefore we assume nga our flux is constant. So if flux is constant, so totong gamiton nga formula, we have PE eddy current divided by PE1. So directly proportional sa tong speed, N2 divided by N1 raised to the power of 2. So mani ato ang gamiton if ato ang flux is constant. So therefore, directly proportional siya sa ato ang speed. So unsa may given sa problem? So sa tong problem, naghatag siya og N1 which is the 500 RPM. And our PE1 for eddy current, we have here 100. So 100 watts. And for our hysteresis, so hysteresis na to, naghatag po siya. We have 200 watts. So to solve for our eddy current for number 2, so substitute. So 100, wala tayo N2 sub, unknown pod, divided by 500 squared. So ang answer ana will be 0.0004 N2 squared. And for hysteresis, so same ang formula, page 1. So N2 divided by N1 raised. So sa hysteresis, wala squared. Okay. So, to solve that, na siya given na pH1 which is 200 N2 divided by 500. So, ang answer ani will be 0.4 N2. So, nakuha na nato, no, for eddy current, eddy losses, rather, for number 2. So, to solve for our N2, or the speed to reduce the core losses by 20%, so we have our formula, PE2 plus PH2 is equal to core losses na to for number 2. So, substitute 0.0004 n squared plus 0.4 n2 is equal to, so reduce by 20%, so therefore 80%, which is 0.8. Multiply sa ato ang total losses, which is 300 watts. To simplify, so simplify nato. So our N2 will be, so shift solve sa ato ang calculator para mas madali. We have 422 RPM. So this will be our final answer for our speed sa ato ang core loss para mo run o maka-reduce by 20%. So for our next topic, we have efficiency. So efficiency is the ratio of output power to the input power. So ratio ang efficiency. So we have here our formula. Output power divided by the input power. So, if na ay given nga losses, so we need to use output power divided by output power plus our losses. So, magamit din na formula if na ay losses nga given sa problem. So, condition to attain maximum efficiency. At maximum efficiency condition, so take note, sa maximum efficiency, the variable losses or copper loss are equal to the constant loss. So, sa maximum di ay equal ang ato ang copper loss of mechanical loss and magnetic loss. So, we have here our formula. For maximum efficiency, we have output power in maximum divided by output power maximum plus 2 multiplies ato ang constant loss. So, take note for this formula for maximum efficiency. So, for our last topic, for our module number 3, we have separately excited DC generator. So, kani nga topic, gamit kayo ni sa ato ang board exam. So, mostly, diri manggawas ang electrical engineering nga topic. So, please take note mo for the formula. So, we have here, the field winding of the generator is excited or supplied from a separate or external DC source like a battery or another DC generator. So, kani di ay excited DC generator, mostly naa siya'y external source or giseparate. Example, ana ang battery or another DC generator. So, we have here our equivalent circuit diagram for separately excited DC generator. So, na siya'y separate. So, here, our E, our source, external, and RA, where atong RA is the armature resistance, armature winding. So sa ato ang armature winding naatay IA, which is the armature current. And we have RF. So unsa man ang RF? RF is the field winding resistance. And our RL, the load resistance. And our IL, so sa RL na to, dapat na po IL. Kaya na may current nga moagi. So we have our load current. And E, natong source, is our generated EMF in the armature. And VL is the load voltage or the terminal voltage. So formula for solving our generated EMF in the armature. So we have E is equal to VL plus IA multiply sa tong RA. So very easy ra ang formula, no? So take note, So kanina formula for separately excited DC generator. So let's have an example for this topic. So the armature of a separately excited generator has a resistance of 0.6 ohm. When run at its rated speed, it yields 132 volts on open circuit and 126 volts on full load. How much power is delivered to the external circuit? So we have here our equivalent circuit diagram from our problem. So ingon, given nato naatay RA daw nga 0.16. So klaro naman, no, sa problem giingon na separately excited generator. So syempre we need to memorize the formula. So RA given 0.16 ohms and our E generated EMF is 132 volts. And for our VL, so tong VL nato, the load voltage in our full load, we have 126. So, ay kalimti ang unit. So, ang giingon, how much power is delivered to the external circuit? So, ang unknown nato will be the PL. So, to draw our equivalent circuit. So, our RA, so connected siya sa atuang source nga generated EMF. So, sa RA nato, na-adjoy mo travel nga armature current. And our RL nato, and our IL is equal sa atuang IA. And our VL is 100. So, mostly kaning E o VL, kuan ni siya mag-atbangay ni silang duha. So, VL is 126 volts. To solve that, so we need to use the formula E is equal to VL plus IA multiply sa tuang RA. So, given man tanan, no? So, our E, substitute, 132 is equal to our VL, 126. And our IA is unknown, walay gihatag. And our RA is 0.16. So, to solve for IA, so IA is equal to 132 minus 126 divided by 0.16. So, sakto ba? I-calculator ni ma'am. 132 minus 126 is equal, divided by 0.16. Our answer will be 37.5 ampere. So, to solve for power, so power man ang unknown. So, formula for our power, so PL is equal to VL multiplies ato ang IL. So, take note sa ato ang separately excited generator, our IL is equal to armature current. So, our VL given 126 and our IA is equal to IL. So, our answer will be 37.5 amperes. So, our maximum, our power delivered to the external circuit for this problem will be, so multiply 4,725 watts. So, this will be our final answer for this example problem. So, I hope nasabtan. So, formula based rin siya, guys. Tuyok ra atong formula ni. As long as kabalota mo identify sa mga given o atuang unknown. So, giingon ni ma'am, memorize the formula para mas mahasa, ma-familiarize ninyo og dali ra mo maka-answer. If you have any question, you can ask me in our Google Classroom. So, thank you and God bless.